It's 6. Hello everyone. My name is Mike Garuccio. I'm a principal technologist at Expedient. And I'm here today to talk about kind of our journey of pushing automation from being something that's, done on a specific team out to being something that's just part of pretty much every engineer at the company's job. So I think it's important to have a little bit of context there first. Slides being difficult, sorry. So I think it's important to have a little bit of context there first. So I want to talk a little bit about who Expedient is. The company was founded in 2001. We're a cloud, co-location, and managed service provider, although our legacy kind of dates back all the way to being a ISP in the early 2000s for dial-up. And we've got locations kind of across the US and a few that are international, and we've been around since 2007. So you can imagine we've definitely built up a decent amount of technical debt and complexity, that kind of thing that we're really dealing with. So this definitely isn't something that only applies if you're doing greenfield work, that kind of thing. And to kind of provide some more context around that, I want to talk a little bit about kind of where we started before we started on this project to kind of change the culture and change the way that we did things. So initially, we had an automation team. They were really created in response to a need for better consistency and better speed in our service delivery pipeline. So at this point in the process, everything was, sorry, fixing audio there. Everything was really focused on the delivery. Our support engineers weren't really involved. It was just that delivery team. And it was really built around existing staff who were familiar with a subset of what those challenges were. So primary ones for us were things like deploying servers, creating cloud environments. So the people who were doing automation work, even though they were an automation team, were really people that were just comfortable doing or learning something new and had a really good handle on what those challenges were that they were trying to solve for. And they were using a graphical orchestration tool, so vRealize Orchestrator, which has its issues, which we're going to talk about a little bit later, but really was great for that initial kind of proof of concept, early win type of work. And they really did get a lot of early wins. The most important one was getting the idea that automation was something worthwhile and something that we wanted to do out to everyone. We're able to solve some problems primarily around server deployments that really did fix a lot of things for us and made it so that management was more willing to automate more things. Got rid of a few of the naysayers who were thinking that none of that was even possible, things were too complex, etc. But after all those early wins, we started running into problems, just like with anything else. And the first one was really that we just have almost too many products and services to actually have one person or even one small team of people understand them that well. So it was great that we were able to start off with, server builds and cloud builds that were relatively simple and well understood by the people on that automation team. Where we then ended up having problems is that same team had to go ahead and start doing things like deploying firewalls and writing the code to do that, or deploying Elasticsearch instances or configuring SANs. And it's just not possible for one team to be able to do all of those things well. So they end up spending a lot of their time working with the teams that are actually doing that work and actually supporting those platforms, just to understand what the requirements are, what the process is, and how they fit into that process, rather than spending their time doing the thing that they're supposed to be doing, which is creating automation. Beyond that, poor source control options, and this really is kind of one of those things where Vero causes some issues, meant that the automation team couldn't grow. Once it got beyond 2 or 3 people, you started stepping on each other's toes. One person making a change in a firewall workflow somehow causes server deploy workflows to fail. So really the automation team had to only be a couple of people who had a really, really deep understanding of that platform and what any change they were going to make was going to do in terms of ramifications throughout the platform. And so at that point, the automation team's a bottleneck. It's not possible for them to get everything that needs to be done in terms of requests that are coming in at them. And at some point, we actually got to a point where they weren't even able to maintain the things that were already created just because there was change happening. The process for deploying that server changed. Now someone has to go in and adjust the automation. So they were not only a bottleneck for new things getting automated, but even for new standards and processes being rolled out, because they were a requirement for every single process that they'd already touched. They need to go in and back in and fix it. So our infrastructure engineers, all being pretty enterprising people and not really happy with that kind of status quo, they just started to automate things themselves. So that was a bunch of point solutions, which is great, but is also problematic. So everyone's building their automation from scratch every single time. There's no code sharing, and more importantly than that, there's no way for, or no common interface. So one person writes a script that you pass command line flags to. Another one has a config file. Another one just expects you to go in and edit things by hand. Some of them are Python, some PowerShell. There's just a bunch of variety of ways that things are being done, not for any reason other than that's just the tool the person doing it picked. Not necessarily that it's the best tool or anything like that. So in the end, you end up with a situation where things are disjointed, and the only people running the automation that's been created tend to be the people that created it, because there's just too much dependency issues, too many different problems, and other people running their code. And ultimately, it turned out that writing code is the easy part. It's not that hard to go ahead and say, all right, I'm going to make a brand new script that goes ahead and deploys a server. The hard part is making sure that that doesn't break any existing processes, keeping it updated, understanding what it's supposed to do, understanding what the side effects are when you run something, how it works into change control. All of those details that are just kind of part of our jobs that we don't think about necessarily as being technical, but are actually bigger challenges than just writing a Python script. So we looked at a couple of solutions at that point. The first one and the kind of obvious one is, all right, let's rip out this Vero thing, or at least downsize what it's used for, move to something more modern that has source control. We can expand our automation team, which does solve the bottleneck problem. Even if it isn't an ideal way of solving it, it does solve that. It does mean that you can throw as many people as you want at the problem, because now you have source control. You can avoid breaking things once you build that process. But it doesn't change the fact that those automation engineers are not going to be experts in the things that they're automating. And if the actual running of the platforms and the actual understanding of the infrastructure is the hard part and not the automation, there's not really a reason for that to be a separate team. So instead, we decided to embrace the great work that was happening on those infrastructure teams. So all those people who went out and wrote code and automated things for themselves to solve their own problems, we wanted to give them a way to do that that was controlled and solved some of the issues that we were seeing with the way that they were doing it, So the way that we went ahead and did that was, first, we created a central platform for executing those workflows. For us, this was Ansible and Ansible Tower, but you could use anything else from Terraform Enterprise, Chef, Puppet tools, SaltStack, since they just got acquired by VMware. Really, the tooling that you're using doesn't matter. The thing that's important is that you've picked a platform that you're keeping everything centralized on. That's going to give you a couple of really important things. Number one is a consistent interface. So there's no more worrying about, oh, how does this thing that deploys servers run? Oh, I've got to go get the right version of PowerShell, or it's all these Python dependencies, and then a whole other process for a different tool. You log into one web interface, you see everything that you have access to run, and you can run it from there. Another nice thing, and this was really important for some of our management as well as our auditors, is it's a central place where someone can go and see every single thing that's happened in the infrastructure for, the last, in our case at this point, 2 or a year or two. But that history will just keep going forward. So we can say definitively when something was done and how it was done, see if there were any errors, really solve a lot of those problems of really more concerns that people are doing things that aren't correct. It also makes sure that when there's a update to the automation code, it's immediately pushed out to everyone because you're all running from the same place. You don't have to double check to make sure there's not a new version that meets some new standard or anything like that. You just go in and run it and don't need to think about these constant updates that are happening in the background, which not only makes things more consistent, but also means that we take a huge amount of cognitive load off of our infrastructure teams, where they don't need to worry about the fact that, we've now changed the registry settings that need to be configured on a server, and they weren't aware of it. They know that as long as they run the workflow, things can happen, or the right things will happen. And then the person on their team that's the expert in that process is defining the workflow. Beyond that, we also decided to use GitHub to store and share code among teams. Again, the tool choice itself doesn't matter that much. GitHub's kind of the gold standard, but if you prefer to use GitLab or Bitbucket or any of the other offerings that are out there, those are all perfectly fine. The important thing here is that you have a single place where all of your code lives, and you can set up branching policies around that code. So in our case, we have individual development branches, dev, QA, and production branch. So when someone decides that they want to go make a change, or they know that they need to make a change to the platform or the process, they check out the latest version of the dev branch into their own personal branch, make changes, and then when they're ready to, they go ahead and merge that into dev. Once it's in dev, they can run down to our tower platform, go ahead and test things out, make sure that they work correctly in our stage or our test environments. Once they're completely happy with it, they go ahead and move that from dev to QA, where they can have other people on their team evaluate it, test it, run it themselves, check over the code to make sure there's no glaring issues. And then once they get approvals from their other team members, they can then merge that code into prod. And as soon as they merge it into prod, the way that things are getting deployed has changed. And then that's the standard going forward. So it really makes it so that all of our organization is built around that single point of control in GitHub. And then we think you see a lot of value from something like that. And then finally, there's probably the most important thing that we did, which is to provide one-on-one training for our existing operations and delivery team members. And this kind of evolved from a few different ways that we approach things. Our initial thought was that we were going to get decent-sized groups of people together with a few people from our automation team, have everyone sit in a room and basically do working sessions, solve problems. Maybe everyone brings their own problem that they want to solve, and we walk them through those issues. Of course, then 2020 happened, so in-person meetings weren't an option. We tried to go ahead and adapt that for Zoom, but it didn't quite meet everything that we were looking for. What we really ended up finding was that there were two types of people in those sessions. One would be the person that it comes forward, takes control, asks a bunch of questions, kind of leads the process, and then everyone else in the room would tend to kind of step back and just become passive observers instead of active participants in what we were trying to talk about or what we were trying to have them learn, which we then found out, when we follow up with them later, a lot of things really didn't click. They weren't asking questions at the time, though, because it felt like that other person was kind of running the meeting. So to avoid that, we ended up switching to just doing one-on-one trainings. And this is the thing that really unlocked a ton of potential for us for different team members. And we're not talking about a lot of those either, or a big time thing for each individual person. Really, what we found is 1 to 2 sessions at about 2 or 3 hours a piece with a person was enough to get them from, I have no idea what Ansible is, I've never automated a thing, to having a playbook running a playbook running in development that they could continue to work on, tweak, and make changes to get it ready to move into prod. And then as they did that and kind of learned and explored on their own, we made sure that there was always a session. For us, it's in Teams, but for your group, it may be in Slack or some other IM system, where they could at any time go ahead and ask the people who were kind of experts on the automation side of things to help walk them through problems, solve things for them. So what that really allows them to do is focus on solving the problem that they want to solve while learning. And it doesn't take that much time from the experts because they're really only sinking in a couple of hours of time during that initial one-on-one training, and then sporadic, dropping in and answering an IM or answering a question in async manner. So just when they have time. And we saw someone go from, again, having never automated anything before, no programming experience, expert on the things that he wanted to automate, but not what you would consider an automation developer, went from that cold start to having a playbook that's in production that his entire team is using in about a month while still doing his existing job. So I think we ended up kind of working it out. He probably spent somewhere between 20 and 30 hours on building the actual playbook itself, with maybe 8 to 10 hours of that being ones where an automation expert was even involved at all. So really a great win there, and that one-on-one training is what really unlocked all of that, because we weren't seeing the success, that same level of success when we were doing the group trainings. So I imagine some of you are thinking at this point, that sounds great, but what happens to the automation team once that's done? Kind of the reverse of, what happens to my job once we automate. In this case, it's all right, what happens to my job as an automation person once everyone's doing it? And they still have a huge role. They're in charge of running the platform. So in our case, it's Ansible Tower. There's constantly things that we're doing to kind of revise that platform, make it better, make it work better, deploying new ways of managing dependencies there, that kind of thing. So they're in charge of that, keeping it running and functional. They're also teachers, and they're providing support when challenges come up. So again, they have those open IM sessions. That really is a core function of that team, is being there to provide help when something comes up. So an example of that is I had someone recently come to me and wanted to know how they could work through setting up static roots on some machines when it was always going to be a different number of static roots every time they ran it, anywhere between 1 and like 15. So I then went ahead and explained the way loops work in Ansible and really gave them some deep dive support on how to solve that particular problem. Didn't need to know anything about the platform that they were working on to do that, though. So that's really where that line was. They brought their expertise from the platform and they were solving their problem. And I was just giving them that one individual piece of information that they didn't already have. And then they could run with it and use that not only in their current problem, but for everything else that might happen in the future. Beyond that, the automation team's job is really to enforce standards and best practices. For us, this is things like making sure that all playbooks are idempotent, that we're not using a bunch of raw command modules, so just taking this awesome automation platform and really just using it to run bash scripts and not telling anyone. And that doesn't scale, creates problems later. So we're enforcing those standards and we're enforcing those best practices. For us, the way that's implemented is a simple addition to our GitHub process, where when someone is going to merge their code into prod, they need someone that's on the team that's responsible for the platform that's automating to sign off on it. And they also need someone from the automation team to sign off on it. We're hoping to eventually move away from that once people are a little bit more familiar with the platform and the way things are supposed to work. But that's kind of where we sit today. And the final thing they do is the hard programming work. So for us, being a cloud provider with, again, a huge range of different things that we work with and do, Ansible was picked because it has a fair number of those modules built in already, but no matter what platform you pick, there's going to be holes and things that it doesn't do. So it's the automation team's job to do that, difficult development in Python or Powershell or whatever programming language your tool set uses, to make those tools accessible for everyone else. So for us, it's things like, we brought in Elastic, we needed the ability to deploy Elasticsearch clusters from their platform. So we went ahead and wrote modules that did that. But once that work is done, they can go ahead and just hand those off to the teams that are actually going to know their process and know their platforms, and they can integrate them with the rest of what they're doing. So an example for us is we have different teams working together to build virtual environments and then apply backups to those environments. We wrote some modules to deal with the backup stuff. We wrote some modules to deal with the VMware stuff and deploying the VMs, handed those off, and then let those teams that typically work together and know their own challenges create the actual automation playbooks and process and procedure around that. So yeah, that's really what you end up with in terms of what the automation team is doing. So then want to kind of wrap up here, so we have some time for Q&A later with a couple of takeaways. The most important one that I want people to walk away with here is that automation is easy and process is hard. So actually just building a tool set and automating things and solving those technical challenges is much easier than integrating that tool set with your existing process in a way that's scalable and accessible for everyone in the company, and allows you to really get the value out of automation instead of just building point solutions that solve single problems. Beyond that, it's empower your teams. We were actually really surprised with the overall success that we had with some of these initiatives. There was a lot of skepticism that the people that were on our existing operations and infrastructure teams just weren't going to be able to do this, and it was going to kind of crash and burn. But we found the opposite. Once we empower people and kind of push them off in the right direction and, put some guardrails and frameworks around them, they were able to solve really interesting problems that would have taken the automation team much, much longer to have a real working valid solution for. But that really is the important thing is around empowering them is building a system where they can be successful. So the reason they were able to do all those things is that we took a lot of that decision making out of it and said, all right, here's the path, here's the tool sets, come to us with problems, and you go ahead and do your thing and be successful with the things that you want to work with or that you're trying to accomplish. And then think about scale early. So this is what kind of bit Expedient when we went down that automation team path, is that we were thinking about the 2 or 3 problems that we wanted to solve right now. And we solved those really, really well. And it wasn't until much later that we realized that the solutions that we created weren't going to scale and weren't going to be a process that we can apply elsewhere in the company. So the real key was just thinking right when you start off about what does this look like if we're trying to automate everything and not just this one thing? What does this look like if our systems are suddenly 5 times bigger than they are today? Because we, who knows, made an acquisition or suddenly there's way more demand for a particular application or anything else that can cause those scale problems. So you want to have that in your mind early and really plan out your entire shift here around that. All right, what does this look like at scale when we're using this for everything? And that's actually it. If anyone has any questions, I'm happy to take those now. If you'd rather, ping me over email or Twitter DM, that's totally fine too. Always up for a chat about any of this stuff or cloud, VMware, anything.
Thanks, Mike. We have we have one question in the Q&A section. I don't know if you saw that one yet.
No, I did not.
All right, it's from Dan. It says, regarding the workflow you talked about, from the code someone pushed and merged into dev's branch, do you have any kind of tests or the person itself checks that it works correctly? Nothing's broken, seems correct before pushing it to QA.
So from dev to QA, that's really on the person that pushed it. So the idea that they're going to push it to dev, really the fact that there's dev and QA is built around the fact that running an Ansible playbook locally and running it in Tower are slightly different. So when they push to dev, the expectation is they're still going to be tweaking their playbook to run correctly in that Tower environment, correctly configuring the job templates around it, that kind of thing. So they're the only person testing at that point. And there's no kind of gating between dev and QA in terms of approvals. So once the person that developed a playbook is happy with it, they're allowed to merge it into QA. Once it's in QA, that's where we expect more testing to be happening, both from them and from their coworkers, to go ahead and validate that the playbook's doing what's expected. There's no surprises. There's nothing weird happening in there. They're getting a check from someone on the automation team to make sure that the code all looks good and they're following best practice. And then it gets merged into prod. Long term, we do have a plan to kind of implement sort of a CI/CD process around this type of thing, where instead of just having someone manually run the playbook, as soon as it gets merged into QA, automatic runs happen, and we go out and do a validation on those. We haven't gotten there yet, though. That's probably a 2021 project for us. We're starting to integrate that into some of our pipelines.
All right. Are there any more questions? If you do have one, feel free to raise your hand, and we'll allow you to talk to Mike directly, or you can put your question in the Q&A or the chat section. It looks like we have a couple more.
Yeah, and I've got those now, so I can go ahead and
Cool.
take those. So yeah, the next one is, was there any management friction between the different groups and doing that cross-training? Surprisingly little. So we were able to kind of sell this to management very early because they saw that they had that bottleneck from the automation team. And so they took a pretty hands-off approach and sort of let the different teams work together in the best ways that they could find. So when we were doing that cross-training, there was some pushback from individual team members that they really didn't have time for this. But that kind of shifted when we went to those one-on-one trainings where they felt like they were getting a ton more value out of it. And then looks like the next one is, what are the sorts of things that I should look for in an engineer when hiring for automation roles? And I'm actually going to be a little bit different than most people here. I think the big thing that you want to look at is someone who has empathy and is willing to understand the way that other people are working and what their challenges are. Again, this may just be kind of my take on it, but to me, the automation piece is easy and the technical pieces of an automation engineering role are easy to train. The hard part is getting people to wrap their heads around the challenges other people are having, the ways that they're currently solving it, and how to help them, as opposed to just, taking a standard operating procedure and turning it into an automation or a script or something like that. And it looks like that's everything. I don't know if anyone raised their hand.
Haven't seen any raised hands yet. But we've got, a few extra minutes. Oh, there we go. We have one from D in the chat.
Building two teams with limited personnel resources. So their question was, how would you recommend building two teams with limited personnel resources, with one team for automation and another for SRE/ops? And honestly, if you have that limited of resources and that small of teams, I almost wouldn't. I would look to get an automation skill set, one or two people onto those SRE and ops teams, and then just have everyone kind of work together around their process. The big reason that we have the automation team at all is because there's Expedient's, there's a couple hundred engineers at the company, and it's easier to have one team kind of overseeing all of these processes, managing the platform, and working with individual operations teams. If you only have one operations team anyway, just add automation skill sets to them and have the people that are automation engineers work with their coworkers to kind of skill them up. That's really my best bet there. It looks like that's from D. Absolutely, if you want to talk more about that, shoot me an email or shoot me a DM on Twitter, and I can kind of dive deeper of your specific situation. All right, and looks like we're just about at 6:30. I don't know if there's one final question from anybody.
All right, it looks like we're all set. So thanks everyone for attending. Mike, great job. These sessions are recorded. I think I mentioned that earlier, but they will be up on the CODE websites. I don't know exactly when they'll be uploaded, but they will be uploaded there eventually. So you will be able to see these sessions again for anyone that's interested. But thanks for everyone attending. And I know that we have one more session. It's either one or two more sessions right now after this one. So enjoy the last of CodeCon. Thanks, Mike.
Thank you.